Welcome. Was that a bit too scary? Okay, so let's get cracking here. So just first up, exercise 2.2 K, I, M, and O. In class, we're gonna go through any of those that people want. So please just jot down now if there are any of those that you want me to go through, and I won't do it as an ed puzzle, but I'll record a video and then I'll post those videos up if there are any of that you want of those. So do you want any or all of those questions? K, I, M, and or O. Cool. So let's head into today's topic, which is solving equations using substitution. And whew, look at this now. I mean, we had fractions before, and now we got fractions with things with squares in the denominator. Now, if we were to go, okay, well, that's great stuff. That's our common denominator. So we multiplied everything by x squared minus 2. If we multiplied this x squared by this x squared, what would we have? X to the power of what? Well, we'd have x to the 4. And the reason I'm asking that and not going much further is now we're going to have x4s and no. I'm hitting undo here because that's no good. Let's stick to quadratics, which means to the power of 2 at most. So it is to the power of 2, but let's stick to solving equations like that. So instead of that, let's say that, oh, hang on a second though, I like what I did with these brackets to start with, because those two look very much the same, don't they? So why don't we say something like, normally we use the letter k, let k be x squared minus 2x. And now let's rewrite this equation again. But anytime we say x squared minus 2x, we're going to write k. So that thing there is k equals 18 minus 45 over k. Whew. Don't you just have a sense of relief at that, going, that seems a whole lot cleaner, right? Not cleaner, but it looks like an easier one to solve. Okay, I think it does. So now we know how to solve this. Well, we've got our LCD. Well, this is over 1 and this is over 1. So what is our lowest common denominator? Well, it's just k. So if we write this side over k and we write this side over k, well, the 45 is staying the same. What do we need to multiply 1 by to get to k? We need to multiply it by k. So in other words, we multiplied that by k, so we're going to multiply the top by k. So what do we have in our numerator now? Well, we've got k times k, so k squared. Same idea here. We had to multiply by k, so now we've got 18k. Denominator is the same. Earlier we said, well, that means the numerator should probably be the same. So k squared equals 18k minus 45. Cool, what's our strategy to solve now? Well, we said that we wanted one of the sides to equal 0. That was generally our strategy. So let's go k squared, and we want this to equal 0. So we need to minus 18k, and we need to add 45. So we need to minus 18k and add 45 to this side. We do it on that side, so we're going to do it to that side. And now we've got something. Okay, cool, well, easy stuff, right? What do we need to do to the left-hand side? Factorize. And we go k, what, 45, 9 and 5 jumps to mind. Doesn't seem to work. What else we got? How are we going to factorize that? Well, how are we going to factorize it? Have you got an idea? What else? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 14. Nothing seems to be looking too pretty, does it? 18 minus 18. What is our thing? We don't have quadratic formula yet. We said 9 and 5 didn't work nicely. 18. What is it? Did you get it? 15, 15 and 3. Right? Okay, so back on track. So what do we got? Minus, minus. So k equals 15 or k equals 3. Okay, cool. Why are we not done? What do we still need to do? Why have we not finished answering the question? Well, we found out what k is, but the original question didn't have k's, it had x's. We had here, this part here, that let k equal x squared minus 2x. So in other words, k equals, what do we say? X squared minus 2x. Or there was a second option. Or k equals x squared minus 2x. Okay, so now we've got a whole lot of work. What do we need to do in this equation here? We want to say one side equals 0. So x squared minus 2x, and let's subtract 15 from each side. Okay, so again, factorize bracket, 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 and we have 0 equals, let's see if we can do a bit better on this one. The last one, I was like, that 15 and 3 stumped me for some reason. And so this one's a bit easier. X, I've got the 3 in my mind, so I'm going to go 3 and 5. Let's go minus, plus, check it. Seems to work nicely. So we've got 0 equals, well, we got that part. We got x equals negative 3 or x equals 5. Whew. Or this side, 0 equals x squared minus 2x minus 3. Okay, this one's a bit easier to factorize, isn't it? Yeah, well, if the answers are integers, then it's a bit easier. So we got 3 and 1, must be, if the answers are integers. So we got 3, 1. What are the signs? Okay, well, we definitely got minus 3 plus 1, minus 3x plus x gives us our minus 2x. So x equals 3 or x equals minus 1. What do we still need to check? We still need to check if you can see that. There we go. There we got the two answers. We still need to check if any of these answers here are invalid. What would make one of these solutions invalid? Well, if our original equation didn't work, here we've got a denominator of x squared minus 2x. So x squared minus 2x, we know should not equal 0. Because if it equals 0, then we're dividing by 0. That's no good. So let's check. X minus 2. So this can't equal 0. So x can't equal 0. And that should be probably an and. And x also shouldn't be 2. Because if x is 0, then 0 squared minus 2 times 0 is 0, right? 0 minus 0 is 0. And if x is 2, what's 2 squared? 4. 2 times 2, 4. 4 minus 4, 0. So 0 and 2. Were any of our solutions 0 or 2? No, they weren't. So then we're good to go. Okay, let's look at one more example. And I'm just going to get you going on this one because the idea is easy enough after that. In this case, what are we going to let k equal? Well, nothing looks the same straight away, but wait a second. Y minus 3, if we distributed that, that would be y squared minus 3y. So suddenly this looks exactly the same as that. So k is y squared minus 3y. Oh, that's a bit much. Okay. What values can y not equal? Well, y can't equal 0 because that would mean this would be 0. And y also can't equal 3 because 3 minus 3 would be 0 and this denominator would be 0. So after that, same strategy as before. You're going to rewrite this equation. Y squared minus 3y is y plus 40 over k equals 14. Lowest common denominator. Multiply out 2 solutions of k, 4 solutions of y. Whew. Quite a bit, right? But luckily there are some few to practice. Now I've put 3 down. Welcome to do more. Exercise 2.3, page 41. B, F, and L. Give it your best go. And enjoy.